high north, far above the Arctic Circle. Approximately 20% of the undiscovered oil and gas resources in the world could lie hidden in the northern Arctic basins. The oil and gas industry puts a great deal of effort into avoiding oil spills when exploring for and developing oil resources. However, should an oil spill occur, the industry is prepared to respond effectively. In order to safely produce resources in icy areas, a joint industry program is carried out to further develop technology to be used in oil spill contingency for Arctic and ice-covered waters. In 2009, a team of specialists prepares for a trip to the Arctic. Their mission is to conduct experiments to determine which methods are most effective should an oil spill occur. Equipped with new innovative technology and equipment, the research vessel Lance embarks on its voyage. The 4-year research program started in 2006 and has been coordinated by SINTEF, a Norwegian-based research and development organisation, with Stein Erik Sørstrøm as project manager.
The main objective was to develop knowledge, methods and equipment for oil spill response in ice-covered waters.
Prior to the field trip, extensive small-scale lab experiments had been carried out by SINTEF. These experiments form an important step in the preparations for the large-scale tests. The area chosen for the full-scale experiments is located east of Svalbard, in the Norwegian part of the Barents Sea. Finally, at the site, the team prepares the equipment. They have secured permission from the Norwegian government to perform large-scale experiments with a limited quantity of oil. This is a unique opportunity to test the actual response techniques in an Arctic environment. Large-scale experiments are crucial in order to test and further develop technologies needed to ensure efficient oil spill response.
When the oil is released on the surface in the Arctic, it will start to spread in between the ice floes. It will pick up water and it will also evaporate, and the properties of the oil will change with time. The main part of our research in this program is to document that the spreading and the processes in the ice-covered waters is much slower than in open water. And this creates a larger window of opportunity for different response techniques. The window of opportunity is the time we have from the oil was released on water and until it's too late to use a particular response technique.
Together with the Norwegian Coast Guard, the team is trying out the first technique, in situ burning, which entails the burning of free-floating oil in ice and oil collected in booms.
The idea behind the in situ burning is to ignite and burn the oil on the spot. So in situ means on the spot. We have to be inside the time window or the window of opportunity for in situ burning and ignite the oil before it weathers too much. And our objective was to look at different techniques to improve or to enhance the in situ burning in ice-covered waters. In our experiments we saw that this method is very efficient. It can remove up to 90% of the oil from the sea surface, and it has a time window which may be as long as 5 days. At least in these experiments we had the 5 days time window, which is important in response planning and response operations.
The second method the team is testing is mechanical recovery using skimming devices.
Mechanical recovery means to collect and recover the oil from the sea surface and maybe also to recycle the oil. We have tested various skimmers in the laboratory and then taken the experience from these tests further and developed 2 new skimmers showing quite promising results for ice-covered waters.
Next, the team is preparing a new dispersant spray unit, which opens up the possibility of new ways of using environmentally approved chemicals in areas where the ice coverage is high.
The purpose of use of chemical dispersants is to break the oil slick into small droplets and cause the droplets to disperse into the sea. It has not been used in Arctic or in ice-covered waters before. When we're using dispersants in open water, we have waves breaking the oil slick down and creating these small droplets. Inside the ice field, we don't have the waves, so we need to apply extra energy. And this can be done by using the prop wash from the main vessel, or we can use the water jet from the mob boat, or we can also use high pressure water systems, which normally are on the vessels. In our experiments, we have seen that the time window, the window of opportunity for use of dispersants is quite long. It can be more than 6 days. And we have seen that it's possible to include dispersants as one of the techniques for oil spill countermeasures in ice-covered waters.
Which of the available methods to use if an oil spill should occur depends on the window of opportunity and the conditions in the area. It is important to choose the response technique that gives the best effect and least impact on the environment. In addition to the various oil spill recovery methods, it is important to be able to monitor a potential oil slick in an area with icy conditions.
When we are going to observe the oil, we need remote sensing techniques. We can use satellites, we can use aircrafts, we can use on-the-ground systems. And we have seen that we have good systems for partly open water and up to, let's say, 30%, 40% ice coverage. And we have quite good systems for solid ice conditions. We still need to develop better systems for the intermediate zone with the high ice coverage.
Her 0,1 grader I vannet.
Based on the experiments and research, SINTEF has developed an oil spill guide. This guide is being further refined to achieve a web-based simulation tool, where users can define and simulate various oil spill scenarios.
The guide will be used mainly for training inside the oil companies and can also be used for planning purpose in the future.
The experiments are finished and the team is heading home. The increasing activity in Arctic waters requires a high level of oil spill preparedness. The experience and results gained through this programme form an important basis for further improvement of methods and technology for oil spill response in ice-covered waters.
Our experience in this program is that the Arctic possesses different challenges compared to open water. We have ice, we have low temperature, we have large distances, seasonal darkness. But we have also learned that the Arctic possesses other possibilities compared to open water. The ice dampening the waves, creating possibilities for more efficient response techniques. So it is possible to find solutions also for oil spills in the Arctic.